Thank you, everyone. Thanks, Pulsar Summit Asia 2022, having me and Jimmy to talk about turn your data into real-time chart and alerts. I'm CTO and co-founder of Timeplus. I have been working in data and big data and AI, BI for like over 20 years. I like different topic like machine learning, and I like data visualization. So, and Jimmy is with me. Jimmy, can you simple introduction about yourself?
Thank you, Gang. Hi, everyone. I'm Jimmy. I'm currently a founding engineer at Timeplus. At Timeplus, I'm mostly focusing on some backend services and operation deployment stuff. Besides big data and streaming, I also very passionate in programming language as well. So I play a lot with them during my spare time. Thank you.
Yeah, thanks, Jimmy. So this agenda will something like this. And first, I will talk about how important the real-time data processing, and then we will talk about real-time data architecture and how we build integration Pulsar with Timeplus and what Timeplus is. And then we'll do some demo about how Timeplus is integrating with Pulsar, different streaming queries, and how we use streaming query to do analysis and show visualizations. And finally, we will show some use cases that built by Timeplus. So first, I'm going to talk about why real time. So we believe the future of data is real time because like in any of the project, the most valuable resources, because time is always going forward and you cannot create it. So because you can hire more engineers, or you can get more money, loan from a bank or from investor. If time is wasted, you cannot get more time. So that's why, the real time is important, because with real time data processing, you'll get the data be processed as soon as possible, right? So it's giving you the competitive advantage if you can process data in real time. According to this state of data racing report, it's a host conducted by the data stacks. It shows that 71% of 500 plus technology leaders believe that they can deliver directly attribute their revenue growth to use of real-time data in their organizations. So actually there's a link to this report if you want to know more about this value of real-time data and what's this survey, you can have it. Next, I'm going to talk about the real-time data architecture, right? So this is actually a data architecture from A16Z. So talking about the modern real-time data architecture. So you can see there's from left to right is actually a data processing, the pipeline from start to end, right? So starting from the data source, you see the various data source, and then we do ingestion and transportations, and then the data has been stored and processed and transformed, and finally go to the analysis and the output. So one thing very critical to the real-time data architecture is actually the rising of the event streaming, right? So for example, the Kafka and of course the Pulsar, right? And AWS Kinesis. I can remember like 20 years ago when I started software develop, I was at that time I was developing some telecommunication management software. We actually start using some event-driven architecture at that time, but that's pretty new. Like we call that like event bus, right? We use something like callbar at that time. So you can call the remote object, you can subscribe remote object. But overall, in the past, the streaming, even streaming architecture, the basis is not so well established. And later on, there's an event queue. So still, but with Pulsar and Kafka and more popular, I think the event streaming becoming a very important part of the data architecture. So everybody is moving their data to like Kafka, Kinesis, or Pulsar. Then there's for the streaming or real-time data, there comes to the real-time analytic database. For example, Apache Jove, for example, ClayHouse and Pinode or Rucksack, right? These are the real-time database. And the other part from the event streaming is actually the stream processing. For example, we have Flink, right? Very popular. And the other part like Materialize, which is a database, but it leverage the streaming processing technologies. For today's architecture, we actually talk about two important parts of this data architecture. That first, we know that Pulsar is work at the ingestion and transportation layer, which is event streaming, it's Pulsar, right? And then actually Timeplus can work as a real-time analytic database and leverage the stream processing. So this is where Timeplus located. Of course, we will talk about the dashboard, the visualization, because these parts are also important to the data analytics, right? So we'll talk about how actually Timeplus also cover part of that functionality as well. So this is the overall position of the various Timeplus and various Pulsar, and give you some architecture point of view on how we're going to talk about today. So next, I will give a quick introduction about what is Timeplus. And Timeplus is actually a purpose-built real-time analytic platform. So which means it's a turnkey solution to turn streaming data into business value. This is a very high-level architecture diagram of Timeplus. From the left is actually the data source. The Pulsar is actually a very important data source for us. That means we believe those streaming data came from Kafka, Pulsar, or Kinesis, and we can build a connection using we call the source to connect all the streaming data. And then these streaming data will be ingest into our core storage engine. Timeplus core storage engine actually contains two parts. One is the streaming store, and also we have a historical store that store both the real-time data and historical data. There is a query engine that will query those streaming data in real time, also combined with the historic data at the same time. So we actually can support a very low latency, high performance streaming query. And later on, we'll show how Timeplus will do that. Timeplus is a platform that means we actually contain an API service, and we contain our own console. That means in our console, user can run the streaming query and build a real-time analytic dashboard of visualizations. And also there's a downstream streaming data. After the data has been processed, we actually can use the sync connector to send those data out to the downstream data tools. Like we can send data to even streaming, we can send data to database, or we can send data to some other like monitor tools like Grafana, or just send alert in a notification like email or Slacks. Like I mentioned, Timeplus is actually a streaming analytic platform. The core is actually a streaming database. So everything the user interface facing to Timeplus is just streaming SQL. So here I give you an example of what the streaming SQL looks like. So first, you can say it's just a SQL query. You can select something from something, and you can run the drawing, you can group by something. So it's just a SQL as you already know. What is different compared to the traditional SQL is actually our streaming SQL is continuous running, and it's push-based. That means once you run the SQL, it's running there for a long time, continuously calculating the incremental data and pushing the result to you. So we'll show that later. And third, there's one important feature for the streaming data, streaming query is actually, because streaming data, I believe, is unbounded. So there's no, there might be start, but there's no end. But when you do the analytic, you have to provide some boundary, right? So that's the window. We are using window function to do the boundary. So like in this sample, we use tumble, and of course we Timeplus support some other window functions as well. including hopping window and also some session window. And fourth, like I mentioned here, there's some watermark for late event. Since for streaming query, we all know that the data are coming in the future, right? You don't know when some data are coming late. It might be caused by the different clock. It might be caused by the different network transportation channel. So some event will come late. So in a streaming query, we use watermark to handle such late event. It's same as what Flink is doing. Last, you can see we actually can join between streaming and tables. So a table is just bounded data set, and stream is an unbounded data set. So we actually can join them, join stream to stream or join stream to table. So that's what a streaming SQL looks like. So next, I will hand over to Jimmy, and Jimmy will give us some introduction about how Timeplus is integrated with Pulsar. And he will also give us some demo on how the streaming SQL looks like, how Timeplus work with Pulsar.
Thank you, Gang. There are a few ways that we can move data between Timeplus and Pulsar. First, we have some built-in source and sink available in Timeplus. That I will show you a quick demo later. And on the Pulsar side, we have also just released a open source Pulsar Timeplus sync connector, which you can easily find on GitHub. What you need to do is just to download the pre-built NAR file from GitHub and run it with your Pulsar worker. Then you can send data from your Pulsar cluster to Timeplus, which is useful when it's impossible for you to expose your Pulsar cluster to public internet. And besides these two, Timeplus also has an ingest HTTP API, which you can access via the link on the slide. If the above two solutions are not feasible for your use case, you can easily build your own solution with this API. And in fact, our Pulsar sync connector is built on top of this API as well. Next, I'm going to show you a quick demo. So here is the web UI of Timeplus. You can access Timeplus via this hostname, beta timeplus.cloud. And you can easily create your own account and create a workspace to get started with Timeplus. It will not take more than 2 minutes. First thing first, before we can do any query, we need to first create a source. As you can see here, we have a topic already created in StreamNative. We are going to use this topic in this demo. In this topic, it only has one partition, which we have some simple cryptocurrency data ingesting to this topic. To get started, we click source, and we can see that Apache Pulsar is available here as a preview feature. And we quickly just put the source name, Pulsar submit, for example. Pulsar submit demo. And we put the broken link here. Topic name. And we support two authentication methods. One is OAuth, the other is token. In this demo, we are going to use OAuth, and we will choose the data format that is in the Pulsar topic. In this example, the data is formatted with JSON. And lastly, we need to specify a stream name for this source to ingest data to. You don't need to create a stream beforehand. We can just let the source to create a stream automatically. And next, if everything is correct, you should be seeing some preview data, like what are available currently in the topic. And then you can configure the retention policy for the stream data as well. We'll use the default here, and if everything looks good, and then we just click create the source. And now the source is ready and running. Now, and also you can see that the throughput shows up here, that a good indication that we have data coming into Timeplus. And if we click streams, you see that the stream has already been created by the source. And click to stream name, you'll be able to see the schema of this data in this stream. So for data ingested from Pulsar, we also ingest the event time and the event publish time from the Pulsar message. So that could come handy if you need those information. You can see that for this data is very simple. We just have the call name, which is a stream, and the price, which is float 32. For Timeplus, this is a built-in field that indicates when the data is when the event time of the data. This depends on the source, of course. And we can run query very quick to show the data. This is a very simple query here, and we just show what data available in this stream. Click run query. As you can see that data just keep coming into this stream. Data come very quickly. And on the top of the table, we are showing some simple metadata of the data in this returned by this query. Like, for example, you can see the corn, what are the available values for the corn. Currently, we have just 2 corns ingested here, BTC and ETH. And the pricing, like the pricing values as well. So we are going to do something a little bit more interesting, like we want to show the price. And only, like, for example, for Bitcoin. And only seeing the data in the table is not very interesting. We also support visualization. Like, for example, for this one, we might want to see the latest data. So you can just see the price of the Bitcoin keep changing and get the latest price as it goes. And also we support different chart times for visualization to maybe to suit your use case better. For example, we can also show the trend of this price changing as well. But since the change is very small, so it's not very obvious how the change goes. So okay, we can set a baseline here. For example, we can use something like 1,400 as a baseline. So which hopefully can give us a better view on how things change here. Now we can see the changes is more readable because we have a baseline here.
Yeah, it shows that the big Bitcoin price is going down, right? It's
yep.
I think 1 hour ago it was still a little bit higher, right? But it's going down and down.
Yep. So besides this, we can easily if we want to send data to Pulsar as well. Like I mentioned earlier, we also support sync. So you can send the data just to a Pulsar topic if we want for later processing. I'm not going to show that here. So that's the demo. Apparently, there are other solutions that you can use besides Timeplus to run SQLs on top of Pulsar. So what are the differences, right? So here are a few solutions that we are aware that are available currently. For one is the Pulsar SQL, which is a seamless integration with Pulsar. Like you can just run Pulsar directly against the Pulsar, just like Pulsar is a SQL database. Compared to Timeplus, I think something we need to keep in mind is that if you want to run Pulsar SQL, right, you have to either operate at the Pulsar SQL server or a channel cluster. That's, of course, you need to pay more effort on the operation side. While Timeplus is a SaaS solution, you can just use it easily without running any of operation side effort. And Pulsar SQL is right now just a SQL engine. It has no UI for visual analytics, which Timeplus, like we just saw, that we can easily use it to see what actually the data looks like. The other one is Flink SQL. StreamNative also provide integration that can run Flink SQL against the Pulsar source, with Pulsar source and sink as well. So this utilize the powerful Flink SQL engine. That means that you can really do a lot with that with this solution. But again, with this, you probably need to run your own Flink cluster, which is not fun at all. Also, similar to the previous solution, Flink SQL is also just a SQL engine. You need to build or find your visualization solution to work with it as well. Lastly, we also noticed that there is a solution proposed in the Pulsar San Francisco Summit that use SQL to deploy Pulsar functions. This also allows you to run SQL directly in Pulsar, but this one first it's new, so it's just for now it just support very simple stuff like no join at all, and also it's more like it's used for data routing and transformation. It's not really for you to analyze your data. So that's very different from the what we are doing at Timeplus as well. So yeah, that's it.
Okay, thanks, Jimmy, for the demo. Next, I'm going to talk about how those client-side architecture has been implemented, how those real-time visualization has been supported. As I mentioned, the Timeplus has a core of database engine. But beyond that, we have actually API layer, which is implemented with Golang. And this Golang API server will talk will host the web service and talk to the client. And our client is actually implemented in React.js. And the interaction between the server and the web is actually the HTTP, and the real-time data is actually pushed to the client side using WebSocket or SSE. So that's our basic architecture. So those data, the real-time data has been sent to the query service, which is a wrapper of ReactiveX. So ReactiveX is a very popular API for asynchronous programming. So there are actually a different language binding, support JavaScript, support Python, support Golang. So we are using this layer to handle the streaming data using the observable patterns. And those data are then sent, we actually build our own data visualization based on the D3.js. If you know, D3.js is actually a very popular data visualization, tools. It's actually not the under the hood is actually just a JavaScript library that manipulating the DOM elements using data-driven method. So you can actually have a bunch of data and binding those data to the visual elements, which actually in most of the cases, it's SVG. And next, actually, our first version of the query API was using the WebSocket. And later on, we actually made some investigations and we investigated the difference between the WebSocket and the SSE. The complete name of SSE is actually the server-side event. So both server-side event and WebSocket can support the server-side push. That means once user run a SQL query, and those streaming query is pushing data in real time to the client side, right? So we actually has a blog talking about the difference, the technical difference between the SSE and WebSocket. So if you visit Timeplus blog, our engineer Kevin actually made some investigation and talking about the how the difference between the WebSocket and the server-side event. So if you want to know more about the details, you can take a look at this document. Based on the usage, what I have so far is actually from the performance point of view, there's not a big difference. But from architecture point of view, SSE is a little bit better because the WebSocket means we create a post, we create a query, and then the client has to call another WebSocket, build a WebSocket connection to get those query results. But with SSE, actually, the user can do these things in one SSE, which is just a regular HTTP post. So that means the query result will be returned or pushed by the server in the SSE in the same HTTP post response. So that may be a better architecture because when consuming the query result, the client side just need to use one request and one response. It doesn't need to create a HTTP post to create a query and create a WebSocket connection to pull the result. So that's why we choose now we choose SSE over the WebSocket. Next, I'm going to talk about something about some other use cases that we have built with Timeplus using the Stream SQL. The first case is actually a fleet management use case. So in this case, we actually have a customer who is managing like 2,000 or 3,000 of different trucks. And in this case, we actually provide this solution so our customer can monitor all their trucks in real time. So whether there's some truck speeding or whether some driver is driving too much without rest. So then we can send real-time alert to the operational team, say, this driver needs some rest. So then it will save a lot of operational cost for our customer. So in this case, all the trucks are actually sending the data for IoT gateway, and then these data are pushed to the Timeplus, and then we use this Timeplus stream query to build a dedicated UI so with map so our customer can monitor the trucks in real time. I'm going to make a quick demo here. So actually under the hood, you can see there are actually a lot of trucks here. So this is the trucks raw data. If you run a query, you can see that these trucks, the stream contains all the trucks data. So you can see all the data are here. So then let's go to the, we have built a solution UI for our customer. So this is you can see we have this map-based monitoring, but under the hood, it's actually just a stream query. You can see actually we are running this stream query to list all the trucks in real time, right? So, and in this demo, we actually have fewer trucks, but in a production environment, there's like 3,000 trucks. Now you can see there to say this truck is overspeeding, has a speed like so we can take a look at this truck. So and see we can view the history speed of this specific truck. See what happened to this. You can view the range. So these are the history data of this truck. So you can just click and take a look at another truck. So see what happened. And we actually have different alert settings. Say we can check whether there's a driver drive too much. So it's a fatigue driving. So we can enable this alert and go back. You'll see there are a lot of driver who is driving too much. But this is just the simulated data. So another case is actually you see the geofencing feature, like other than overspeed and a fatigue driver, we actually have this into the region. We actually monitor whether this truck is going into a region or is going out of a region. So for example, this truck is actually, we say it's into area. That means this truck has been running from outside the region into this region. And we can take a look how this query looks like. We can go back to the run this query back to the Timeplus console, right? So actually, you can see that in this query, we actually query the latitude and longitude of this data point that truck is running, and then we actually compare the lag function as actually return the last data point of this specific truck, and then we use actually using over partition by function. That means we actually monitor all the trucks in the real time. So it is partitioned by the RPM, which is actually the car ID. So we monitor all the truck and compare the truck's position. If the current position is in the area and the previous position is out of the area, so then we believe this truck has been running into the specific area, and then we can send an alert. You can see that we actually using this simple query to monitor all the trucks in the real time at the same time. So that's the fleet management use case. So then another use case is actually we call the observability, right? Because you can actually using the streaming query to monitor your infrastructure. Timeplus is actually running on the AWS cloud. Under the hood, it's a Kubernetes cluster running in the EKS. So we actually have a pipeline that collect all the container logs and the container metrics, right? And then we send all this data into Timeplus, and so we can build a monitoring solutions that monitor all the infrastructure. It's another workspace of Timeplus, which contains all the we actually collect all the data and send those data into Timeplus. See, there's a metrics data, there's a logs data. So all this data are sending to Timeplus. So let's take a look at this logs data. So you can see all the data are sending to Timeplus. It's actually the data is actually just a JSON format, and the raw logs are here in the message, right? And leverage based on these data, we actually build a monitoring dashboard or monitor solutions. So in this case, you can see we actually running those queries to monitor all the EC2 nodes. This is where and we monitor the CPU, memory, disk of all the nodes, and 2 of these nodes have very high CPU the memory consumption. And then we have actually we use there's containers. So we actually monitor the CPU and the memory of all the containers separated by the namespace. For example, this is my namespace. I create a lot of test applications or test jobs. So one of those jobs is consuming very high CPU. This is actually the name of this container is Fleet Simulator. It's actually running the fleet data generation. I just show you in my previous use case, right? So generating those data really consume a lot of CPUs. And also we can monitor the memory as well. So in one of the case, there's the container called Kafka. So we are using Kafka in this case, which use a lot of batteries. And then we actually can monitor all the applications. So in this case, we are we actually using those logs to monitor the request per second. It's actually our Kubernetes log that give you the web access information about about our Timeplus. So we can take a look at how these queries were running. For example, if we take a look at this query, how we monitor the CPU. So you can see actually we are the first thing I want to say, like the raw data is just a tags of JSON, right? So we actually can can run field extraction at runtime. So we got all the values, the raw data values, and we do the conversion. We actually this is the matrix data that contain the CPU load. So we calculate the CPU load, and we group by the where the namespace is host and the load is this, and on this specific node, right? So if we run this query, you can see that we got the CPU load, we got the usage, and on this specific load. Another thing, we can take a look how this container monitoring. So actually, here we have a little bit more complex query here. Right. So in this query, we actually run a CTE. First, we check we get something from this CI weather matrix. So we got which is the matrix name is container memory usage. So, and we filter out something that we do not need, and we get the container name, we get the memory usage values, and then we actually run a tumble window. We actually, based on those raw data, we do our aggregation for half minute, like 3 second memory for we only got the latest, because for this memory usage we only care about latest. So every 3 seconds we get the latest memory usage. So that's how we monitor the memory in this case. Okay. So of course, there's a case we can monitor the logs as well. So in this case, we actually run a query that is based on the tumble window of EKS web access log. And this is actually a view. And this view is built, we can take a look at this view. And I can copy this view back out of the Timeplus. So actually you can see we are using this view to extract information from all the raw logs. And we're actually using a grok function. This grok functions will define a pattern. And once it matches the pattern, it extracts all the information from the log and give you some structured data. So that means we turn the unstructured log into a structured data format. So let's run this view, and you can see what happens to this query. There's some logs coming. You can see actually we turn the raw log into something called event, and this event is actually a structured data. So all the field has been extracted, and later on you can use all this extracted field to for your query. So that's a two basic use case, and so let's have a wrap up on today's talk. So the first, we believe the future of data is real time, like in what we mentioned today. Actually, a lot of vendors, they leverage the real time data, like Amazon, they're using real time data to do real time recommendations. Banks are using real time data to do transaction anomaly detection in real time. So it is for sure that real-time data is important, and it will be the future of the data infrastructure. And today, the technology to support real-time data is becoming more accessible, like Apache Pulsar, so like Kafka, right? So with those infrastructure, with those technology, it's very easy for the customer to build real-time allocation compared in the past, right? So we use even streaming, we use streaming processing, or we using streaming database. So we show that in today's demo how easy it is when you combine with Apache Pulsar and Timeplus, so you can build an application and show the analytical result in real time very easily. Like I show in my in the architecture slide, right? Pulsar is event streaming, and Timeplus is a streaming processing database. Combined together, these two, we can build a powerful, low latency analytic applications. So we show some real-time query cases where Gimi show you can get some data in real time from Pulsar and analyze this data and show the visualization. And also we can build some more powerful use cases like what I showed. We build a fleet monitoring cases, and there's DevOps cases where we monitor our own infrastructure. With all of these, I would like to say, the future of data is real time, right? And Pulsar, Timeplus, and all these real time data tools will make build real time application much easier than ever. Thank you for having us. That's all for today.